Hello, good afternoon. Our topic for this time is about the drives in robot system. As we all know, there are different drives that are being used in controlling robots, and the most familiar are the pneumatic drives, the hydraulic drives, and the electric drives. Now I'm going to discuss more of hydraulics and how do we compare hydraulics to pneumatics and to electrical drives. So first we have to define first what is hydraulic, what is pneumatic, or what is electrical. And I think I have some tabulation here that discusses about the merits of each drive. Let me pull this out. Okay, so here, as you can see, there is this comparison of electrical, hydraulic, and pneumatic as far as driving of systems are concerned. Not only robots, every system uh, like machine components or machine that are being used in productions or any project of that sort. Uh, so here, first we define the three main drives: electrical, hydraulic, and pneumatic. So electrical is, as we all know, is being driven by mostly the component is motor, whether it is DC or AC motor, or the others are stepper or servo motor. And the other two is this hydraulic and pneumatic. As we all know, these are fluid components or fluid systems devices. This one is a system that makes use of oil. So we're talking of machine hydraulics as compared to the hydraulics that are being used by civil engineers or sewage engineers, which is hydraulic engineering now in civil engineering sense. This is using oil because we are in industrial, meaning in machine domain. So pneumatic is the branch of fluids that or fluidics that makes use of air, and not just an ordinary air. It is compressed air, compressed. So meaning it is not the air that we feel in the atmosphere or in the wind. That is not the pneumatics that we're talking about here. It is the compressed air, no? Because our atmosphere or the environment that surrounds us is the atmosphere, and the pressure here is only 14.7 psi, meaning uh, psi is pound per square inch. So you have to have an inch here and square, no? So pounds per square of an inch, no? So that is psi. And we don't feel that pressure much now because 14.7 is very manageable. If you want to feel the pressure of air, you go to the vulcanizing shop. There is a pressure for refilling the tire of the pressure, air pressure in the tire, and you can adjust the pressure uh, as you want, no? Because the pressure of the tire of a certain car is like 35 psi or let us say 40 psi. And as you can imagine, as you can see, the car or the truck, if you have a truck, no, that truck can be lifted by the tire, and inside the tire is this bunch of air which is 45 psi, but the truck is capable of carrying heavy loads like so many machines or many things, logs and everything. No, so from the atmospheric pressure of 14.7 psi, and then you put that pressure, you increase that pressure to 45 or 40 or 30, and you put that into the tire, then it could lift an enormous amount of mass or load. Okay, so that is pneumatic. Hydraulic, the example of hydraulic is in the, for example, in earth moving machines like bulldozers or backhoe, no, or so many machines like stamping machines and forming machines and many more. Yeah. So here, as you can compare with respect to forces, I think we're going to discuss later the the capability of each drive system. But for now, I would like to emphasize that hydraulic is used mainly in large forces. You know, so this uh, hydraulic system is used in large forces. This one is in rather small, no, or erratic or fast, like the ones used in the door of a bus or train, yeah, in LRT. Yeah. So we have here the three drives: electrical, hydraulic, and pneumatic. Then we have to evaluate this one by one in terms of energy source. As you can see, there is an energy source here, energy source. No? So for electrical, the source of energy, of course, it's coming from outside, no, from substation or from electric utility. Hydraulic, what drives hydraulic is also electric, no, electric motor. The electric motor drives the pump. So basically, it will not function if there's no electricity, or it can function if you have another form of prime mover, which is diesel or gas, no? Gas engine or diesel engine. Then you couple this to the shaft of the pump by coupling. Then you can drive the hydraulic system because you can drive the pump. The pneumatic is, of course, it is also driven by the electric motor or diesel driven. So pneumatic, the compressor is driven by electric motor. No. Energy storage is the second criteria. As you can see here, the electrical has only limited capability of storing its energy, and normally we store the energy using the batteries. No? But how do we store, or I mean, do we have large batteries available? Of course, we don't have. The dimension of batteries are only limited. For example, the batteries of the car, like 12 volts or 48 volts, and then you're gonna put that in series or parallel. Yeah. So in that case, it is limited. Also in hydraulic, the energy storage is limited because we only have the accumulator. The accumulator is where you store the energy. There are different kinds of accumulator, and we are going to take that up in another video. Okay, sorry, let me put a blank space so that we can illustrate better what we're trying to discuss. So here, accumulator. So we store the energy of the hydraulic system in accumulator. Aside from the tank, there is also called accumulator. It is a vessel that has a gas or kind of a diaphragm in it. So when you are operating the hydraulics, it is powered by this fluid, and then the pressure is going up, and then the bladder, some kind of rubber rubber casing, the bladder is being pushed up. But once the power is lost, then that stored energy will be the one to provide the necessary power to for the system to continue. So now we go to the pneumatic. Why is this good? It says good reservoir. No? So we put the power of the pneumatic in the reservoir or the tank. Now this there's a metal tank. I'm gonna show it to you later. So, but the reservoir is just continuously taking energy from the atmosphere. So we have a lot or limitless air supply from the atmosphere or from the air, and then we are going to compress, and then we put in the reservoir. But the air is not going to be empty. The air is just everywhere. It's limitless. There's an unlimited supply of air. That's why we have this very good source of pneumatic energy or compressed energy. But of course, the electricity is also going up. I mean, the consumption of electricity is also going up because the motor is continuously uh, rotating, to compress the air. So here we go to the next distribution system. Excellent with minimal loss. Electrical. So we see the efficiency of electrical, especially now that we are having a sophisticated control system in distributing electricity or electrical power. Hydraulic limited, basically a local facility. No, because hydraulic, you cannot just build a big hydraulic plant like a building. No, it's like a modular type per machine. Unlike electricity, you can have the application of electrical power is limitless. Here, pneumatic good can be treated as a plant-wide service because you can have the the good structure of a pneumatic system from a very large compressor. Then you can put the air system or air pipes and air tubes, no, in the whole plant, like the hospital. Now, for example, there are mm, air tubes or air circuits in the hospital because it is being used, yeah, in the application of sucking the phlegm or other applications like providing oxygen. So there are pneumatic lines in the hospital everywhere, no, and also in the other buildings. Now we go to the other interesting criteria: energy cost. Which among the three has the lowest cost for electric bills, and which has the highest? So lowest is the electrical, because electrical is most efficient in distributing energy. This one, hydraulic, is medium, and this pneumatic is the highest consumption, or highest in the consumption of energy, no, cost. I mean, you are going to pay so much bills in pneumatic. Why? Because the air coming from the atmosphere. You get it from the air, you compress. Then after using the air, after using the compressed air, you're gonna throw it again back to atmosphere. You cannot return the used air in the compressor, because the compressor tank or the reservoir has a higher pressure, like 10 bars, no, 10 bars. What is 10 bars? Like 100, no, 100 psi, but the atmosphere is just 14.7. So you just cannot put back an air which is a very low pressure, like atmospheric pressure, and push it into the tank which has a higher pressure. No, it will just be purged or kicked out. That's why that makes it the highest among the three for consuming the energy cost. You get the air and then you compress, then you use it, then you throw. Unlike in the hydraulics, after you use the oil, you don't throw the oil. You just don't throw the oil outside the plant. Otherwise, your hydraulic will then be dysfunctional. It will not have um, the necessary energy to continue, because the oil is just returning to the reservoir, meaning the oil that is used is returning to the tank. Okay. And electrical, it has the lowest, because uh, it's just continuing to supply, from the grid, from the utility station, and so on. So rotary actuators, we go now to this criteria, rotary actuators. So the rotary actuators, AC DC motors, good control on DC motors, AC, there are cheap motors. So in rotating motion, what we're talking about here is the rotating motion, um, the rotating motion of a certain of using electricity or using motors. Nothing beats the motors, so it's really intended for rotational motion, the motors, although there are motors that are capable of producing linear or translational action, like the linear motors used in high speed, high capacity elevators and some robotics application. Here, what about rotary motion with respect to hydraulic? Low speed, good control can be stalled. Yeah. For example, if you're trying to observe some trucks which are used in mixing the cement or the concrete, now there is a hydraulic motor there for rotating this body or cylinder, no? So it is used because it is capable of controlling a good control in speed, and there is no short circuit, there's no overload, because in hydraulics, no overload, no, doesn't exist. It just goes back to the tank. So when there is excess pressure, so the overload pressure will go back to the tank. Unlike here, when there is an overload, it could damage the coil of the motor, so the stator winding or the rotor winding. But here, nothing will burn here. Here, the motor immediately burn after it senses the overload. But here in hydraulic, it will just go to the tank, not the overpressure. Now, in terms of pneumatic, wide speed range, accurate speed control is difficult. No. So here, controlling the speed, especially for rotating, is rather difficult, because you have to have the steady supply of air pressure to attain a very good control of speed. When the pressure of air goes down, when the pressure of the air is reduced, the speed is reduced. And then when you try to pump again, or to compress again an air, and then the pressure will go up, then rotary motors of pneumatic will also increase its speed. So it's kind of difficult or erratic in terms of rotary motion. So what about here in the linear actuation? So linear, I think the very good system here is the hydraulic, no, and the pneumatic, because they are really designed for linear movement. So this is the cylinder. So what the cylinder does is just to go forward and go backward linearly, go forward and backward. Same is true with the pneumatic. No, the pneumatic will just go forward and then will just go backward. So linearly. What about the linear actuation in terms of use, in terms of the motor? So now, right now, there are motors that are capable of converting rotary to linear, and the others are really having a linear motion. So we have these linear motors, which make which makes use of magnetic electromagnetism, magnetic bearings, or magnetic levitation, such as the trains used in Japan or Germany or China. Japan and Germany or China. So they have this magnetic levitated uh, motors, meaning it's straight rather than rotational. It is making a straight motion. Controllable force possible with the solenoid. This one is solenoid. DC motors complicated by need for cooling because when a large load is being tackled, then the whole system is getting hot, no? And it should be cooled always so that the windings of the solenoids or the motors will not be affected. This one, the controllable force, is very high. Now, as I told you a while ago, the forces for hydraulics are very high. So you can see this in the construction or in the heavy equipment for machine production, like in the automotive industry and etc. So hydraulic forces are very easy to control in hydraulics. This one, controllable medium force, because it's pneumatic, it's a little bit lesser of force, lesser force in terms of control with respect to hydraulics. So the last one is this: points to note: danger from electric shock. There's always danger in uh, in considering the electricity, like electric shock or this electric risk. For example, there's a faulty wiring. It could have a fire. Uh, it could damage everything. Here, the only downside is leakage, dangerous, as the time is passing by. If you are using your system for a very long time, then leakage will go there because the pressure, high pressure, will go into the fittings and rubbers and gaskets, and we could not avoid sometimes the leaks. Now the fluid will come out, and then it's really dangerous, and it's also open for fire hazard, because oil is really a friend of fire. Now, it's like a fuel for the fire, because the fire is being developed with the three elements. So you have to have a fuel, for example, wood or oil. In that case, hydraulic is the oil. Then you have to have oxygen or air, which is abundant in the atmosphere and heat. Okay, so if you are using hydraulic too much, then the oil gets heated up. So because of friction, fluid friction. So if there's a heat, and there's a fuel, which is the oil itself, and then there is oxygen or air, then you could have this combustion or fire, which is very dangerous to a plant. So that is the three elements of fire, or fire triangle. Fire triangle. Here, the downside of pneumatic is the noise. The noise, it's very disturbing. Normally we have only the by standards we only have like 75 or 80 decibel, decibel allowed, decibel A allowed, so that our hearing will be still in good condition. So above 80, like 90 or 100 or more, our ear, or parts of the ear like the eardrum, will be damaged. So pneumatic has a very annoying noise, like uh, no. And if you are hearing that noise for 24 hours or for a longer time, and of course it will be very irritating, and it will damage your ears in the long run. So this is the comparison of the three drives used in robotics: electrical, hydraulic, and pneumatic. In the next, or in the following video, I will explain the motion of hydraulic and pneumatic in terms of motion configuration, like the A plus, A minus, meaning forward and reverse. Because what this hydraulic and pneumatic does is more of linear or translational motion: forward straight, backward straight. So basically only two, forward and backward, but there are systems that can stop at any given position in between. So there's a neutral position, but we are going to take that up in the next video.